Perfect. Perfect. Okay. Hello, everybody. Welcome to our next Passive House Q&A session of Smart Plus Academy. Today, our guest is Jessica, and she is a really interesting figure. I thought I've known her forever, but I actually just met her in the designer course a while back now. But I've seen so much about her and I've heard so much about her over the years. That's the reason I think it could be really interesting to find out who Jessica is and where she is right now and what she is doing. Yeah, so welcome to our Q&A sessions. Today we started a little bit different. I want to start with a few slides because I realized that a lot of people are asking for who we are, who's Smart Plus Academy, and what is Passive House. And as we are public, it's probably good if you're doing always a little bit of training as well, because that's what we are. We are an academy and we are teaching. So let me tell you a little bit about us. So today Q&A session about Passive House. It's always the first Wednesday of the month when we're doing this Q&A sessions, and it's a Smart Plus Academy event. So who is Smart Plus Academy? Smart Plus Academy, or Smart Plus, making our world a better place. That's really our mission, what we want to do. And why we do what we do? We want to empower people to make a difference. And we want what we do. We are on a mission to decarbonize the building industry. That's our mission. We want to make sure that the building industry is decarbonized. That means that we're not creating CO2 any longer, like that bad gas that goes into the atmosphere. Don't know if you heard about it, but the IPCC report part 3 just came out. I had a glimpse into it already. I'm saying a few things later about it. And we in the building industry have a massive opportunity here to make a difference, and that our work that we're spending in the industry is making a difference. So that could be really interesting. So how we do it, we inspire and lead with passion and love. And that's really us. That's Smart Plus Academy. We want to empower you, we want to inspire you, and we want to make a difference in the building industry. And what we normally teach is Passive House. So what the hell is Passive House? Often that is something that is not understood. Passive House is explained in 30 seconds. Passive House creates a healthy and sustainable building that is affordable. Passive House separates the indoor environment from the outdoor environment. While the outdoor environment keeps changing all the time, the indoor environment stays between 20 and 25 degrees. So how is this done? We're creating a really high-performing building envelope. So a really good winter jacket that works in the winter to keep us warm, but it is well working in the summer to keep it cold. So it protects us from the outdoor environment. And then we're having a fresh air supply 24/7, that the indoor air quality is always good. And we're making use of free energy harvesting and heat recovery. So that is what this Passive House is doing. So Passive House, from tiny to high rise. Passive House could be any building. Yeah, it could be a tiny house or it could be a skyscraper. Doesn't matter. It's working. It's easier for bigger buildings. So commercial is actually easier. And in Europe, Passive House developers win big projects because they're more cost effective. So that might be good to know. Here in Australia, we're not there yet. We are newer to that thing, but we're getting there. And it is definitely cost effective and has a return of investment. But not only for buildings, Passive House is starting to as well move into city planning. So Passive House cities, we're having these cities for whole towns and cities, for residential buildings, student hostels, hotels, kindergartens, offices, laboratories. All that is possible in Passive House. We are working on a science lab right now that is getting certified. And yeah, Passive House can be applied to any building that is conditioned. Here we're seeing the China example with 1.2 million square meters of floor area. And here in Germany, in Heidelberg, more than 100,000 square meter of Passive House. And that is all built to Passive House. So what is Passive House? Passive House is comfort with clear conscience. Passive House is just normal buildings built better. The additional cost is normally between $250 and $750 per square meter, conditioned area. and that is normally resulting in 5 to 20% more. For residential, in commercial, it's normally can be as little as 1% or 0 or negative, but people don't believe it. That's the reason I say as little as 1. One big thing, what we want to achieve is Smart Plus. We don't want you to design and build passive houses. So that's not what we want. We don't want you to tick just another box and say, tick, passive house done, happy days. We don't want you to tick boxes. Yeah, we want to empower you to build healthy and sustainable buildings that are affordable so that you can design and build them. I think this is far more important to us than actually fulfilling a passive house standard. And we teach you how to do that in our courses. So we want you to be able to do educated decisions and decide if the passive house standard is the right thing for you. Often passive house is not good enough. I often say passive house is the worst standard that we can build to. Everything worse than passive house is not acceptable, but we can build better than passive house. And then in 5%, it's an overkill and may make no sense, but it's less than 5%. So this is what we do, and this is what we do with our main 2 flagship courses, the designer course and the 3D course. So these little strange looking things there, the QR codes, everybody has seen them, I think, during the pandemic now. So if you have a mobile phone, you can just hold the mobile phone camera on that, and then you can scan that QR code, and that brings you to a little form where you can register your interest for the designer course or for the 3D course. And then, yeah, we send you more information about these courses. So if you want to. These QR codes come up again. So if you miss it right now, no worries. We will talk, we'll show them to you later again. So passive house in Australia might be good to know. The first new build passive house was in 2013 in concrete block. And as well, the first ENAFit, so retrofit, was as well in 2013 in an existing timber frame structure. And the first apartment block was built in 2017 here in New South Wales, the Fern. But not only this has been built over the years, we have as well university buildings, especially Monarch University has multiple buildings already. Here, that's a steel construction. And here, the first major developer in Victoria is now getting on board. So passive house, we have over 50 certified passive houses right now, but not everybody necessarily goes for the certification. We have already achieved passive houses for less than $2,500 multiple times. Even in this climate, we're coming to these figures. Like I know of one project that's $2,515 per square meter right now in Victoria. So we can achieve these figures even in this climate today. Passive house does not need to be expensive. But please keep in mind, guys, you cannot get a house for $2,500 a square meter with all the bells and whistles, with your golden sinks and all that stuff in your building. This is affordable housing where we go to with 2,500. We can go below that, far below that actually, even with passive house. But guys, don't expect golden sinks for $2,500. That's obviously a different price class. So it's ideal. A passive house is ideal for social housing and affordable housing. So now today, our interview, like I said before, is with Jessica. Yeah, Jess, I don't know, but I have the feeling I know Jessica for such a long time, but I think the first time that we spoke was actually just before the course or during the course. And but I had the feeling I know her because so many people spoke about Jessica and what she's doing in the industry and how she's influencing the industry and trying to do good in building physics and building science, especially on the blow-door testing side. And that's the reason I thought Jessica might be a really interesting person that you may want to meet a bit better. Here you see again QR codes. One is for Instagram and one is for LinkedIn. Again, when you scan this QR codes, then you get directly to that link where you can find Jessica. But we show you that again. Okay, so let us start our interview with Jessica. So before we start, first of all, Luvi, you want to read out Jessica's bio?
Yes, absolutely. Thank you, Daniel. So Jessica is a building designer who took a very early interest in function over form, rejecting design from performance. Her career started with code compliance, with Nation House Energy Rating Scheme, and other complexities of energy efficiency section and the NCC, and grew to include airtightness consulting and blower testing for both residential and commercial buildings. Her passion for building performance has snowballed over the years. She is thrilled now to be entrenched in building science because she believes this is where the real difference can be made. She is also passionate about educating industry and has facilitated many live demonstrations and training seminars on airtightness presented at conference, as well as having articles featured in numerous publications. She has enjoyed sitting on judging panel for the Master Builders SA 2019 and 2020 and 2021 Building Excellence Awards for the Sustainable Building category, amongst others, and look forward to being involved again in the future and watching the innovations in this area continue to grow. So once again, we're very happy to have our special guest, Jessica Allen.
Hello, Jessica. Jessica. Did we miss Jessica? Jessica, you're muted, so we don't hear you right now.
Hello.
Cool, perfect. Hello, Jessica. Great to meet you and having you here in the Q&A session. And yeah, thank you. And thank you for taking the time.
You're welcome.
Yeah, and like this interview, like all the interviews, but this one in particular, I find it really interesting because I can ask you questions that I never got the chance to ask you, and meet you a bit better and know who you are. And I think that would be interesting for a lot of people out there.
Well, I hope so.
So, Jessica, let us start a little bit about yourself. So tell us a little bit about yourself and maybe where you've grown up and yeah, how much you want to share about yourself. Yeah.
Okay, so I was born in Adelaide in South Australia. I spent my early childhood there, and then my father's work took us around the country to a few different places. We lived in Queensland for a number of years. So yeah, I grew up between South Australia and Queensland. Yeah, I was very lucky to spend my teenage years in the tropics. Took full advantage of the islands around the place, and yeah, it was good.
Cool. Then let's jump in directly into Passive House, because I think you know about Passive House for quite a long time. So when and how did you hear about Passive House the first time?
I learned about Passive House, I can't exactly remember. It sort of like just became part of me, like osmosis. I started out, as Libby said earlier, in code compliance, minimum code compliance assessments, thermal simulations, and finding out about Passive House. You know, one of the things about code compliance is that what you assess isn't always what gets built. And so Passive House assures the fact that, you know, what you assess actually gets built. And yeah, I that really was something that I think is important, because what's the point otherwise? So yeah, probably about, I've been wanting to do the Passive House course for probably 3 years now. And I finally got to do it last year, so pretty happy about that.
Yeah, cool. Yeah, like I was really surprised. I thought, Jessica, she hasn't done the course yet?
Yeah, I know, really, right?
Surprised. Yeah, that's like,
I feel like I should have done it years ago, but I didn't get to, but I finally got to. So yeah. Yeah,
cool. So how was the course for you?
It was fascinating. It was challenging. It was more challenging than I expected. You know, mentally challenging. All of the sums and equations and numbers and things like that, I found a little challenging, but very well supported by yourself and Julia. So you know, it was a well-run course, and just generally fascinating. And one thing I didn't know about Passive House was that there is actually a financial modeling system built into it. I didn't know that.
Yeah.
So, you know, you hear all this, you know, talk about Passive House is too expensive. Well, actually, you can ahead of time figure out what the outlay and the return is going to be, which is extremely important, because making those decisions in any other assessment, you can't do that. You know, in a building code assessment, you know, you tell someone they need double glazing, that's going to cost them an extra this many thousands of dollars. There's no return on investment calculation you can do on that, and they think, well, why? But with Passive House, you can calculate all those numbers, and that's really important.
I think it's one of the biggest misunderstanding of Passive House, that they always think it's expensive, and that it is so over the top. But it shows, like, the calculations show that there's a return of investment. Obviously not in the first year, like
it's not immediate.
But over the lifetime of the building, it's there. It's so funny, like when I done the designer course, like I've done it as well far later than I should have.
We get there eventually.
So I've done like multiple Passive House conferences. I've done modeling in PHPP for the European Union, and I've been building Passive Houses and everything. So I've been really working with Passive House every day, and I said, come on, now finally do the course. For me, it was like puzzle pieces coming together. This is what really, like, I known it, but now I was able to connect it, and all this dangerous half knowledge that is out there. Like I was able to eliminate that half knowledge, and now able to connect it, and it was, for me, really fulfilling in a way, like getting this feeling that the things come together.
I think for me too, coming from a compliance background, which is, you know, minimum, and then I'm getting an understanding of Passive House, which is the gold standard, and understanding the space in between. You know, I think that was really valuable as well.
And like it's the gold standard, but we have as well the ruby and the platinum and the diamond, and like
that's
that.
Right.
Like, Passive House is not, it's not the ultimate. It's a standard that is it's designed for economical reasons, like it is. And we can go far farther. Like we can go zero energy buildings. We can go plus energy buildings. We can, like, there's so much more we can do that is far beyond Passive House, what the normal Passive House standard is saying. But with the tools that we have, the PHPP, that Passive House planning package, we can even assess this part on an economical way. And that's the beauty. And the beauty of PHPP for me is instant feedback. Instant feedback. All other, like you've done modeling. Normally, soon you do 3D modeling and you press the button, you can go for a cup of tea or for lunch.
And then every time you make a change, you've got to re-simulate.
And that is that massive advantage of PHPP, and that's the reason why PHPP is an economical optimization tool. Because I can say, give me your 3 windows that you have. I can tell you now which one is the most economical option. Like this costs you $5,000 more, but in 5 years it gets a return of investment. And that's the beauty of it. But I started talking now.
No, you're right. That is the beauty of it. I don't think a lot of people understand. Like, they think it's just a building standard. There's actually more to it than that.
There's so much more. And as well, where it comes from is the part, like Wolfgang Feist, that is like the father of Passive House. He he was a student, like he was just doing his doctor degree, and he had no money, and he had to find the money to build a house. And in that process, he built the Passive House standard. So the affordability was always upfront, was always there, because the most sustainable approach is useless if nobody is doing it because they can't afford it.
Absolutely.
So that's the biggest issue we're having right now. But there's so much.
I know. We can talk about that stuff.
So let us go back to you. So what are you working at right now, and what's your job in the moment? Because I'm not really sure what's happening.
So I started a new job in October last year. I worked for a company called Climasure in the Adelaide Hills. Climasure are a Proclimer distributor, Proclimer membrane distributor, and we also do consulting, passive house consulting, fee, airtightness, just general building science and building optimization consulting. It's a sort of the reason that this company was started was because it's owned by a man who is a builder, and he started looking into energy efficient building for his own company, which led him to the Proclimber membranes, which led him to passive house, which led, you know, as these things happen, it snowballs. And he thought, well, other people need to know about this stuff. This is really important. And he started Climasure a couple of years ago, and then employed me last year to sort of take it off into the direction it needs to go. So that is essentially my job, is to help people build better buildings, and that's essentially it. That's my career mission and my job.
Okay, cool. So you're pretty much developing that consulting side for Climasure, is that right?
Yeah, the consulting side and the membranes as well. Yeah.
And blow-door testing, are you doing that as well as a?
We are doing blow-door testing, yes. I'm doing we've got a partnership with my previous firm, and we do blow-door testing in partnership with them.
Okay. Yeah. So on that, because like you have tested so much more houses than I did, and you have so much more experience with blow-door testing. So what are the main challenges for people getting buildings airtight? What would you say is the main challenge for them?
Well, knowing that it's a thing for a start.
Yeah, true.
And builders who don't understand it, who don't think it's priority, and don't factor it into their costing, like the time it takes to pay attention to detail. Yeah, I would say the biggest challenge is the building industry and the lack of awareness, the lack of awareness in general. Once the awareness comes into play, there's nothing much that stops you, because it's not rocket science to get a building that's slightly, you know, you don't have to go to passive house standards to get a better building. So once you know about it, you know, identifying an air barrier and paying a little bit more attention to penetration isn't that difficult. Making sure that the joins and materials are sealed up properly. And, you know, it's not rocket science, it's just awareness. Yeah.
For me, it's the biggest challenge is that the industry understands that airtightness is achieved in the design stage.
That's right.
I think that's the biggest challenge. Soon you think about it and you make sure that, like, we call it the green pen test. Because
we call it the red pen test.
Yeah, exactly. We call it the green because airtightness is green, thermal is red. So we make it the green pen test.
Yeah.
And it's making sure that we're able to continue this line everywhere around our thermal insulation, that our thermal insulation is always protected from that internal air. In cold climates.
That's what I mean about awareness, I guess. Like, you know, the architect has to be aware, the builder has to be aware, the client has to be aware. You know, it's a communication problem.
And then the buildings get airtight, and now they say, now the building's getting too airtight. We're not getting air any longer. We are suffocating.
That's another problem. People think they're going to be in a hermetically sealed box and they're going to suffocate.
Exactly.
Many conversations like that.
But the thing is, buildings that are not airtight, they have accidental ventilation. And I even go farther and say it's incidental ventilation. By incidents, I'm having ventilation, and then the incident is over and I don't have ventilation. And that's the thing, like when there's a pressure difference, yes, then I have that airflow, but soon that pressure difference is not there. It's not there. And maybe I've built a bedroom super airtight because it just has a window and there's nothing special in there. And now that bedroom where I'm spending a third of my lifetime is now super airtight, and I have no controlled ventilation in there, and it's raining or too cold out there. I'm keeping the window closed, and now I'm having a really bad sleep because the air quality is not there.
I know you have experience with that too. You gave us a little anecdote.
Oh yeah.
About a place that you lived in.
So I think this is the biggest misconception about airtight buildings. We design them airtight, and we are designing the ventilation for the building. So we could have vents in there. It doesn't need to be necessarily mechanical ventilation, but we're having now vents in there that we can close and open. theoretically, and now we're getting fresh air into the building through a controlled opening, and we're not having an air supply through this dusty, dirty fiberglass coming into the building, and we're having now a clear airflow direction. Yeah, and like soon the air goes through that mold, that build up, and we have mold grows in there. All that spores come in and out, and it's like there's a reason why we have such high asthma rates in Australia. Yeah. So for you now, especially in the blow door testing side, what would be the biggest difference between a passive house and a non-passive house project for you? What would be the biggest difference testing that?
Biggest difference testing. I mean, a blow door testing process is fairly standard. There's a different way of measuring a passive house in terms of volume than there is measuring a standard house for a blow door test. So the takeoffs are slightly different. And when you test a super airtight house, the outdoor conditions really matter. So with a not so airtight house, a little bit of wind fluctuation is okay. If you're testing a passive house, you really have to have quite a still day. Otherwise, your readings, like the pressure from indoors to outdoors, it fluctuates too much, and you don't get an accurate reading. So you do have to have quite still conditions to test a really airtight home or building. Yeah,
and then as well, this automated function. Run the test, do it for me, lean back, doesn't work.
No, you have to be on the ball, you have to be watching it, you have to make sure that the readings are going to be stable when you take them. Otherwise your results will be invalid at the end. So it is more stressful and making sure that you get the right number of readings at the right pressures. I've had some incidences where in between ring plate changes, the pressures, I can't get them to match up. I can't get them close enough.
I had that as well.
And that's a real problem, because again, your results are invalid if you can't get them close enough. So that's something else that I find challenging.
Especially with ring changes or closing holes. So depending on which blow door you're having, there's a challenge.
I've come across that a few times.
So because we're doing it in a more exact measurement. Like if you're measuring 10 air exchanges, 0.5 air exchanges is not such a big difference, but on 0.6 air exchanges, what the passive house requirement is, then obviously 0.5 air exchanges is like, massive. Okay. What would you advise people that would like to go into passive house, like putting that into their design practice or into their building company? What would be your advice? Is there something that you realized, that's something I should do or should know, or what are the pitfalls that they may have run into? Is there anything?
Pitfalls. I don't think, I mean, the business I work in is very much in this industry. The people that are attracted to our business are very much already converted to this way of thinking. So I guess you have to be really ready to educate and spread the word. So, you can't expect this work to sort of fall in your lap. It's a job that you really have to, and anyone who does passive house is going to be the same as us and believe in it. You have to be really willing to go and have those conversations and to drive it and to show your belief in the system and be a bit of a Pied Piper.
I think like especially when you're new to it, it's a lot of sweat and blood.
Yes. And the PHPP spreadsheet is mind-boggling when you first look at it. So you also have to be patient. I
think at the beginning there is a bit of sweat and blood, but then like in the long run, it actually optimizes your whole practice on the design side and on the construction side. And that's the reason why in Europe they're winning these big projects, because their whole company is now designed so there is this control everywhere through the whole process, and by that everything is optimized and more efficient, more effective. Yeah, the biggest issue I see is that clients come with a finished floor plan and say, I want this. Yeah, and then say, your form factor is like totally out of it, and like it's, or like you have 500,000, this costs 5 million. Yeah, so this is what I see a lot. And as well, I often see them already having it lodged with the DA and then say, now we want to make it a passive house. Yeah, so I think that's, for me, get a passive house designer involved as early as possible. That's for me.
That goes for any sustainable design, even if you're going down the passive design route, you know, just slightly optimized for the sun direction. You have to have the right people on your team from the start who know about it. Otherwise, you make wrong decisions all along the way and then expect, you know, a magic wand, just like airtightness. You know, it's not a magic wand. You have to get it right from the start. And that's, you know, part of that promotional mindset is you have to get people on board at the beginning, and we actually do have a client like that at the moment, and I'm really excited to start working with him.
Okay, cool. Then you have done all the passive house designer course and you're certified. Congratulations again. And would you say you have changed your approach to things, or would you say there's things that you're doing different now after the designer course, or are there things that are easier for you now after you've done the course, or is it giving you more confidence, or where you at? Did that make a difference for you during the course?
I think window performance makes more sense to me. I'm used to dealing in U values and solar heat gain values, solar heat gain coefficient, but I think breaking it down and understanding how much the installation of that window also matters was a bit of a clarifying moment for me. And the ventilation is something that that's not my area of expertise, the HRV. I know that you need it. And now I know how to sort of design one, how to do that. That was also something that I took away from the course.
Cool. Were there a misconception or something that you realized, I always thought it is that, but it is something different? Was there anything like that?
The biggest misconception was the financial modeling. I didn't understand that was part of it. And that was a really cool thing to find out. Misconception. I mean, I had a conversation with somebody before I did the course who told me that even the toilet water is taken into account or something. And I was like, whoa, that's crazy. Like everything has a conductivity value. And, you know, so.
There is, even the toilet fluid, there is an option now to actually calculate it. You don't have to, but you can.
But just the fact that you could, you know, was cool. Misconceptions, I don't think so. I think I went into it pretty open-minded and pretty happy to accept it, whatever came at me. But I was very pleased to see the financial modeling aspect.
Okay, cool. Then where could people find you? Like LinkedIn and
LinkedIn's the best place for sure. Email is also good, and the Climasure Instagram page. So the contact details that Luby put up at the beginning are the 3 best places to get in touch with me.
Okay, cool. So let me share them again. And thank you for your interview. We will continue the interview regarding blow-door testing and passive house blow-door testing in the member section, where I want to discuss a little bit the volume calculation and why we do what we do. And there's a few things that I can update you on how to do it. And there's things we can do actually easier. So if you're a member and you're doing this work, then it probably makes sense to join us in that one as well. Let me share your details again. Here, these are the details, so you can scan these codes or make a screenshot of the whole page and then type it in by hand. That's as well an option. So after this, I want to go to the questions that we received from the public regarding no, not pen. Is a pointer regarding passive house, or what came up for us. So question of the public, steel frame New Zealand, building a tiny house with steel frame in New Zealand. What would you recommend for insulation and thickness? Don't. So especially in a tiny house, think about it. It depends now, like there might be a way how you could get it done, but the problem with a tiny house is every millimeter counts. Yeah, like I don't know if it's a transportable tiny house. Now you have to think you have to get it on the road, and the steel frame itself is such a massive thermal bridge, so that can't be really a part of the thermal envelope. So if you're able to get like a rigid board external that you can fix to that steel bracket that is only 20 or 30 millimeter wide, it might be a C shape or something, and now you're using that 20-30 millimeter for your running your cables or something, that might be an option. But I would really try to avoid a steel frame if possible, because in a timber frame, for example, you could use the width of the timber for your thermal insulation. With a steel frame, you can't really. In a house, it's not such a big thing, but in a tiny house, I would be careful. Hopefully, I'm not ruining anybody's dreams here right now. The best option, I think, for tiny houses, and hasn't been really done, I think, is SIPs. Yeah, like structural engineered panels. So they're having a panel like an OSB outside, an OSB inside, and then a PU foam in the middle. That would be, I think, the best build up for tiny houses due to the width of that structure and the rigidity of that structure as well. So that's what I would say. Then internal heat pumps. Yeah, internal heat pumps. Can you place your heat pump inside your home to suck the heat from the space? Yes, you can. When I wrote my thesis, I was actually calculating that benefits, and I thought back in the day how smart I am, and I can calculate it. It's about 2 Kelvin, if you want to know, like 2 Kelvin of temperature that I can drop. But when I need to remove heat, the sun is shining. And when the sun is shining, your energy is pretty much free if you have solar on the roof. So having the heat pump internal, I think, is a good thing. Like the heat pump hot water storage is a good thing, because that heat that leaks out of your storage is now staying in the building, and in the cold season, that's when energy is far more expensive in the future. Then you can have that benefit of not losing that heat. For a heat pump storage internally, because of and then using the air from inside and cool the inside air by putting that air, like, okay, heat pump is a fridge in reverse. Or like a fridge is a heat pump. So for people that don't know what we're talking about, so think about a fridge that works the other way around. So when you go to a fridge, in the back of the fridge, it's warm. So these ribs out there, they are warm because we are sucking the heat out of the fridge. Yeah, and we can turn that now around so that these ribs outside of the fridge are actually now cold, and inside it's warm. Yeah, that's what we're normally doing with our domestic hot water. So that's now our domestic hot water storage. So it's similar size than the fridge, and like the storage is obviously more from an energy perspective because of water instead of air. But here now that ribs external get cold. So if I'm now having a hot climate, I still want to have my hot shower. So now I still need my domestic hot water. I can use now a heat pump, and now the back of that fridge, in this case, the back of my my hot water storage could theoretically be really cold and cool now the building. This is normally, like, you can have about 2.1 Kelvin. So you can reduce the temperature by 2.1 degrees by doing this if it's done smartly. However, normally from an economic perspective, this cooling internally is, if it's a self-made option, is maybe not the best. There are now compact units that do all that. So they're called compact units. It's a heat pump that is ventilating, that is creating domestic hot water, and that is conditioning the building. And now with them, you can have a cooling function in there. Cool. Then question from the public regarding PER. Should we use PER requirement if our grid is not yet renewable electricity? If this is really from the public, I'm not sure. So PER, not everybody knows what we're talking about here. That's primary energy renewable. So the primary energy is, for example, if you speak about the coal in the ground has an energy capacity. Now I have to dig up that coal. I need to bring that coal to a power plant. I need to burn that coal. And then with that burning, I'm having a mechanical movement. So I'm creating steam, mechanical movement. And then out of that mechanical movement, I'm creating electricity. And then electricity is moved to my building. And then I'm having my kilowatt hour in the house. So coal has a factor of 6. So 1 kilowatt hour in my house is probably 6 kilowatt hour in the ground. So I need to produce 6 times, I need to dig up 6 times the energy out of the ground to get 1 kilowatt hour of coal in the building. So now that's primary energy. Renewable is now a new way of looking at the calculation of this primary energy. So the primary energy calculation before was looking at the source of the energy, saying I'm using coal, I'm using nuclear, I'm using water, I'm using, okay, normally it's electricity, I'm using wood, wood stove, pellet stove. So we're looking at the form of energy we're using. And by this, we're having that problem that renewable energies are now giving benefit to electricity producing gas power plants, coal power plants, nuclear power plants, and now it's greenwashing this energy with this PE calculation that we have done traditionally. The PER calculation is not doing that any longer. So what we are doing now is actually we're looking at the use of the energy. Are we using it for heating? Are we using it for cooling? Are we using it for dehumidification, for domestic hot water, for appliances, for lighting? And now by the type of using, we're giving it a weighting, because heating is only needed when it's cold. When it's cold, there's less renewable energy available. That's the reason we have to have a bigger factor in there. Cooling is needed when the sun is shining. When the sun is shining, I can use instant solar energy from the roof. And that's the reason my factor is far smaller. So I said for coal, we had that factor 6. For cooling, we have the factor 1, because 1 kilowatt hour of electricity produced from my solar system is 1 kilowatt hour of electricity delivered to my house. So it is not a problem that the whole industry is moved, that the whole industry hasn't moved to renewable energy yet. And this way of calculating is not any longer in favor of fossil fuel. Yeah, it's a different way of calculating. So if you've never heard of this, sorry guys, that's now really geeky. If you've heard of it, maybe that helps you to understand it a bit better, where it comes from. And we have to move to renewable energies definitely as quickly as possible. I don't know if you know it, guys, I've mentioned it before, but the IPCC report just came out, the mitigation of climate change. That's the section 3. And Jim Skier was just saying, it is now or never. If you want to limit global warming to 1.5 degrees Celsius, without immediate and deep emission reduction across all sectors, it will be impossible. Yeah, that's what he just said 2 or 3 days ago in this interview. Now, why do we see the houses on here? Yeah, on this report that just came out, because we have the biggest impact, the building industry. Like 21% of the global GHG emissions come from the building industry. So from producing buildings and operating buildings, commercial and residential combined is 21% of the global emissions. If you look at the whole impact on the CO2 tons, so we are looking at 12 gigatons of CO2 equivalent. So we're looking at the impact on the environment, and we're calculating it now into CO2 measures. And here the building industry has an impact, or the buildings have the impact of 21% of the global emissions. What is bad, but it is as well good, because if you're working in the building industry, you can really make a difference. Yeah, you can really make a difference. Here we see now that what can we do? And we see the new buildings with high energy performance, in other words, passive house, has the biggest potential to reduce CO2 in the building industry. Here, this color coding tells you how much it costs to reduce 1 ton of CO2. The issue with this graph is it only shows how much it costs to do it, but it's not showing us how much it saves us to operating buildings. So I haven't read the whole report yet. It's just, what was it? 1,900 pages. So couldn't read that in the last 2 days, guys. Sorry, I'm not that fast in reading. But I'm pretty sure that the miscalculation here is that they're only showing the cost of energy performance in buildings and not on the savings on the other side, at least in this graph. I haven't read the whole report, so I will give you more information on that in a webinar in the future. But for now, yeah, keep in mind that the energy performance is where we can really make a massive dent in the impact of our industry. And this is up in design already. So when we're designing new buildings, that's where it happens. But that's just a little upfront. I will put a webinar together in the future regarding that. And then I will explain you all what we can do in the building industry and how passive house fits into that. And if passive house is actually the right thing. So I may learn something in there and probably stop teaching passive house. I don't think so. But I'm reading that report and I'm assessing the findings in that report regarding what we're doing. Yeah, because we want to do the right thing. We want to make a difference, and that you can make a difference. If you want to know more, yes?
You're sharing your presenter screen, just so you know.
Oh, that's good to know.
Might be a bit bigger if you share the other one.
Yeah, let me share the other one. Yeah, because it always goes to screen 2. So if you want to know more about the cost effectiveness of passive houses and if it is too expensive, there is a webinar coming up on the 13th of April, so this month. And there I will be talking about passive house in Australia. Is it too expensive? So go into the costing. To this webinar, there's as well an article coming out this week, expected to come out this week in Build It, that magazine. If you're a HIA member, you get it in your post. On page 20 to 21, there will be this article about that as well. But obviously the webinar will go far deeper into the whole topic. Cool. Then, yeah. As well, maybe you don't know, but the passive house education is now existing for 15 years of passive house designer education. And if I got the figures right, we're having now 13,000 certified passive house designers that went through the training, 13,000 people. If you haven't done it yet, join the team. Yeah, do the passive house designer course. And the tradies started 10 years ago. In Australia, I think we are here since 5 years teaching, 5-6 years now. And tradies, there are, I think, about 9,000 certified people. We need especially more tradies. We need normally 4 tradies to 1 designer. That would be the right ratio, because you're putting our dreams into reality. And that's the reason we need more tradies that can actually do what we want to achieve. So 1 to 4, so we need far more tradies, definitely. Here again, our courses, the Passive House Designer course and the Passive House Tradie course. So if you want to become a Passive House Tradie, this is now the link. If you want to know more about this course, how to become a Passive House Tradie and what's in the course. So you can scan this QR code and then you get the information. So the Passive House Tradie course, that is for the certification, includes the Palama course, the certification course, the exam prep and the exam, and we normally always sell it as a package. If you are an owner builder, you may want to do just the course and the Palama course. Maybe you don't want to do the exam prep and the exam, but it makes sense if you're an owner builder or you want to build a house. Probably a trading course could be as well a good investment for you to understand what they're all talking about and what we can actually achieve. The course is built like an intro, the opaque, like intro about Passive House. Then we speak about the building envelope, the opaque building envelope. Then we spend a lot of time on the windows so that we understand the windows, then the ventilation, the conditioning, a little bit about the economics and retrofits. So all that is covered. So we look at new builds and retrofits. Besides, you get as well a formula sheet we put together with a lot of mathematical helps, like this triangle that helps you transform your formulas. And it's really like we designed it so that tradies understand it, or that you understand it, designer and tradies. That's what we've done. And then you get your certification. We're having a certification guarantee. We're having with the tradies 100% success rate. Global average is 87. So with us, you get a certification guarantee, and we have fulfilled that to 100% over the last 2 years. And we have normally 20%, we have certified 20% of the English-speaking tradies already. So it's like with the online exam, we are 20% that have actually been doing that. If you want to know what's in the course, like I said, it's the Palama as existing content that is recorded. You get that as recording, and you're getting all your you get our homework and exercises as recording, and the access to that is for 3 months before the course, so you can prepare yourself for the course, and then 3 months after the course. And then you have these live sessions with Julia where she explains bits and pieces about how to do it. The course itself is unfortunately not recorded yet on the tradie side, but you can find all these courses here on the website, our courses, or you just scan this QR code and then you can fill in that form, and then we'll come back to you. Becoming a designer or a consultant, you can as well download a PDF on our website. So if you go to smartplusacademy.com.au, then you'll find this little pop-up coming up. You can download a PDF with a preview of the Passive House designer course. Here again, we're having our Palama for designers. We're having our certification course. We're having our exam prep and our exam, and that all comes together in our course. So the course days is the first day is the introduction, A day. Then we're having our opaque building day. We'll speak about the whole building envelope. Then we're spending a whole day on windows, and a whole day on ventilation, a whole day on conditioning, so heating and cooling in a lot of steps. And then we look at the economics and how to calculate it. And then we look at retrofit. And at the end, we're looking at the software, the PHP and Design PH. Here, the formula sheet is far bigger. It's 27 pages, I think, right now, or maybe now more, maybe probably 30 already. In the designer course, we're having one project that we are following through. It's like this little spa home. And this spa home is designed in Germany, in Frankfurt, a 2-story house, north-facing, sun, northern atmosphere. So that's the entry is on the north side, so it's facing away from the sun. Then in the software day, we're going through the Design PH with the building, and then we're going into the PHP, we're calculating it and bringing it ready for certification. Cool. And then again, certification guarantee, we're having an exam success rate of 98% in the first attempt. Global average 87, and we normally have 15% more points than the global average, and we certified 236 Passive House designers in Australia already. If you want to do it, just scan that QR code and then we see you there. Content available in recordings. The whole course is available as recordings. The full content is there. You're getting all your homework and exercises, all the units as recordings 3 months before, 3 months after, and you can download that on our website, Smart Plus Academy, and that's where you can find the PDF. Cool. So now that was our Q&A session. Thank you again to Jessica for being here. I hear your details again. After this, let me just double check. I think that was the last thing I want to say publicly. After this, we are moving now to the member area only, where we dig into the geeky stuff about loader testing and the questions that came from UN. So we go in all the bits and pieces. Thank you, Jessica.
Thank you, Daniel.
Thank you.
See ya. Bye, guys.
Bye.
And everybody.